the polynomial 2x power 4 plus ax cubed plus bx minus 1, where a and b are constants, is denoted by p of x. When p of x is divided by x squared minus x plus 1, the remainder is 3x plus 2. Find the values of a and b. I'm going to use two approaches here, and then you pick the one which fits you, okay? One, I'm going to use long division. So we have here 2x power 4, then plus ax cubed plus bx minus 1. And then here we have x squared minus x plus 4. X plus 1, that is our divisor. Now we divide the first with the first, the rest we multiply. This divide by this, we get 2x squared. So I'll write 2x squared here. Now everything we multiply by this here. So we shall have here 2x to the power of 4. And then this times this, we shall get negative 2x cubed. Negative 2x cubed. And then when we multiply with a 1, this one will be 2x squared. Then we subtract to eliminate this one here. Now a minus minus, that one becomes a plus. So we shall have a plus 2, then x cubed. Okay, and then here there is a 0, x squared, then minus this 2. So we shall have minus 2x squared, and then negative 1 minus, so that will be, there is also this bx now minus 0 here, so I just slide these two here, plus bx minus 1. Now, we again divide. We divide until the power of this x here is less than the power here, okay? So x, this whole thing divide by this, we shall automatically remain with a plus 2. Then here x has to be, because you have this x power 3 and then x power 2 down here. So this one reduces this by this 2. And then you remain with that x there, okay? So that's why we have this one here. Now the rest we multiply all through. So x squared times this, we shall have a plus 2, then x cubed, and then minus x times this one here, we shall get minus a plus 2, then x squared, and then 1 times that, then we shall have a plus 2 of x. When we subtract, automatically this one has to go, and then for x squared here, we shall have minus 2, then minus minus, then a plus 2. So you can see that this one adds up. So we shall have negative 2, then plus a plus 2, then we shall remain with only a there. So when we remain with a, it is the one that we are going to have here with x squared, and then we shall have plus b here, then minus this one here. So we shall have b, then minus a minus 2, because the negative here affects everything here, okay? Then this one here of x, then negative 1 here. And now this is x squared and x squared, so when we divide them, that one disappears. So we shall have an a here. So now this times that one will give us ax squared, then this and that will give us negative a of x, and then 1 times that one will give us an a. Then when we subtract, this one will give us, of course this one will go, and then here we have b minus a minus 2, then minus minus, that one will become a plus, so plus a, then the whole of this is of x. Now you can see that this one and this one disappear, and then we are going to remain with b minus 2. So the coefficient of x is going to be b minus 2 of x, and then this negative 1 here minus the a. So we shall have minus 1 minus a. So this is our remainder. Now this remainder of ours here is this one here. So we shall say b minus 2 of x minus 1 minus a is the same as 3 of x then plus 2. Then we equate, okay? The coefficient of x here is supposed to be equated to this 3. So we shall therefore have b minus 2, which is equal to 3. And when this one crosses, it becomes a plus, and our b becomes a 5. And then this constant part, negative 1 minus a, has to be equivalent to this 2 here. When I take 2 here and then I take a here, a will become a positive, then the 2 a minus. That means a is going to be equal to negative 1 minus 2, and that will be a negative 3. So that will be our answer. Now the alternative approach is going to be this one. Alternatively, remember when we get the polynomial is supposed to be equal to the quotient, okay, times the divisor, then plus the remainder. Or I can write it all together as quotient times the divisor, then plus the remainder. Why is it like this? You can have something like 7 over 2 is equal to 3 whole number and then 1 over 2. Okay? So that means if I multiply all through by, this is 3, then plus a half, right? That is 7 over 2. So I can multiply all through by 2, then I have 7, which is equal to 3 times the 2. You see, this is the quotient, this is the remainder, the divisor, and then plus 1. So this is the remainder. So that is why we are having something like that. Now, our polynomial is 2x power 4, then plus ax power 3, plus bx minus 1. The quotient, we don't know it, okay? So we don't know the quotient here. But the divisor is actually x squared. What do we have up here? X squared minus x plus 1. Then the remainder is 3x plus 2. Now I ask myself, what should I multiply with x squared to get 2x power 4? That one will be 2x squared. So I'll write here 2x squared. Now that means this one here is a quadratic expression, okay? A quadratic times a quadratic, then you get a quartic equation, okay? This means that I'm going to put other constants. Let's say this is c and maybe this is d, okay? So I'll put cx and then a d here. I have to put in the decreasing powers of x because this is power 2, this one has to be power 1 and then power 0 here, okay? Then my mandate is to expand everything here and then I equate coefficients. So this times this, we shall get 2x power 4. Then 2x squared times minus x, that will be minus 2x power 3. And then this one here times 1, that one will give us 2x squared. Then cx times x squared, that one will give us cx cubed. And then cx times minus x, that will be minus cx squared. Cx times 1, that will give us c of x. And then d times everything here, we shall have dx squared minus dx, then plus d. And then we shall add the 3x plus 2. 3x plus 2. Now we can simplify these terms here. We have 2x to the power of 4. Then x cubed, we are seeing this one and this one here. So that will be c minus 2, okay? So I'll write c minus 2, then x cubed. And then the next one is going to be x squared. So we have this one here and this one here. Okay, so that is d minus c then plus 2. So I'll have d minus c then plus 2. That is x squared. And then for x, we are seeing c here, and then minus d here, and then a 3. So it will be 3 plus c minus d. 3 plus c minus d. That is for x. And then the constant, we are seeing d and the 2 here. So d plus 2. Now we equate coefficients. So the coefficient of x power 4 is a 2, and here it is a 2. Then we have the constant. Let me begin with the constant, -1, and then it's equal to this one here. So I'll say -1 is equal to d plus 2. That means when you bring this one here, it is going to give us d as a -3, okay? Then from there, I can go to the coefficient of x squared. Now, this way we don't have x squared. That means its coefficient is a 0. There is something here, plus 0 x squared. So I'll get this 0 and I equate it to this one. We shall have d minus c plus 2 is equal to what? To 0. Now, already, let me take the c this side to become a positive. Our d is -3, then plus 2, meaning c is equal to -1. Now, we are left with finding a and b. So, for a and b, that is the coefficient of x cubed, that is a, then is equal to the coefficient of x cubed here is c minus 2. C minus 2. So, we shall have our c is a -1, then minus 2. Do you see that our a is equal to -3 as the one that we got here? So that is that. Then to get b, that is the coefficient of x, we have b is equal to this one here. So 3 plus c minus d. This is 3. Our c is a -1. Our d is a -3. So when you put minus 3, that one becomes a plus. So meaning I'll put plus 3 here. So 3 plus 3, that one is 6 minus 1. That one will give us a 5. So b is going to be equal to 5. So do you see that it is the same value we got up there? So any of the methods you use can get you to the answer.